I'm Chad Nikhazy. I'm Executive Vice President of Business Development and Account Management at Provisions Group. I know many of you. We are an IT consulting and staff augmentation firm in Franklin, Tennessee. If you don't know us yet, though I think most of you already do. Today's presentation is going to be data integration in cloudy IT. I know what all those things mean. I also know what platform as a service means. And that's sort of the end of my of my knowledge. I don't know what queues, buses, or streams are, and I can only assume Eric Hendrickson, our CTO, is going to tell us what those things are and why they matter, regardless of which cloud environment your data happens to be in. So that's what we're up to today. This is designed to be interactive. So when we first started doing these webinars, we called them town halls, and that was at the beginning of COVID, with the idea that we were gathering to share knowledge in our community about tech topics. It's still designed to be that way. So Eric's going to teach you some things. But we are open to questions and comments along the way. He'll give you opportunity to do that. The event or the session today is being recorded, and so don't let that hinder you from speaking up. We'll send you a link to the recording after the event that you can watch again or share with those who are unable to make it. So without further ado, Eric Hendrickson is Chief Technology Officer at Provisions Group, and he's going to tell us what all these weird words mean. Eric?
Hey, thanks, Chad. I actually don't know, so I thought you were going to do it for us. Is that not? Oh, I'm just kidding.
I can tell you what a bus is and stream. I couldn't have spelled Q that way, though.
Well, and what's funny about buses, actually, a quick anecdote before we get started. Megan and I both, Megan's our head of marketing, didn't know how to spell buses. We didn't know if there were two S's in the thing or not, and we had to look it up. So there you go. So that's the plural of the bus we're talking about, though I believe there is another version of this plural, which may also be right. So in case you thought it was misspelled, you're both right and wrong, as we were in our first couple of cuts. And also, I realized this name. It's funny, Chad. I'll mention a quick story about a conversation we had. You're like, I'm not sure if is it supposed to be cloudy IT or cloud IT? Well, it was meant to be. It was meant as a double meaning a little bit and meant to be cute. Here's the thing, right? And this is what we'll talk about today. Not only has the world of integration changed in the last certainly 20 years, but in the last 10 years or less. The approach to how you do integration, which has changed both by or really all three, by the volume of data we have to integrate between systems, the speed at which businesses operate, and the expectation and the increasing expectation for real-time integration or as near real-time as possible. And lastly, the cloud. The cloud itself has so profoundly impacted, and we'll of course directly talk about this today, how we approach integration, that it is cloudy. It's a little confusing. And so in that way, cloudy was a double entendre a little bit. It was meant to give a nod to cloud, but also meant to suggest that it's confusing. And so hopefully today, if I do my job, you'll leave today's conversation not as confused about what the integration landscape looks like in terms of designing and implementing integration solutions, but also what three of them, relatively new entrants. I mean, we've been doing queues and buses and streaming to some extent for, 15 years. But, again, cloud introduces all kinds of interesting capabilities, in many cases, increments to what you could do before. But also, like a lot of people at the advent of the public cloud, sort of struggled. Like, what do you mean? I'm not going to be able to go into my data center and poke buttons or watch blinky lights, right? So that transition led to all kinds of interesting ambiguities. And so I think with PaaS, it is cloudy what these things do and how to handle them, and then obviously which one to use in which circumstance. So we're going to deal with all those things today. Thank you for this. This is our February webinar. Chad did a great job. That's me, and that's what's going on today. We're going to do this in 4 buckets. I mean, if you've been in any of these webinars in the past, this slide will look vaguely familiar. The icons are different, the section titles are different, but the structure is pretty much the same. And we do that on purpose, right? The goal is to not spend cognitive cycles or cognitive load on orienting to a brand new approach every time we talk. The goal would be just to use this same approach and give you just some new facts and new information. So the framework remains the same, even though the facts and data are different. So we're going to talk about the past of data integration and get you sort of caught up to today's landscape in platform as a service and how that has affected that. We're going to talk about these three, what are called event-driven patterns or message-driven patterns. These are not exactly interchangeable, but they, for the most part today, they will be queues, buses, and streams. Then we'll talk about, cloudy solutions. I mean, we'll try to map these event-driven patterns, particularly queues, buses, and streams, to the three major public clouds. And then lastly, I'll give you, I'll call it a practical approach to deciding when to use each. It's not going to exactly be hard and fast, and as we'll talk about in a minute, some of what leads to the cloudiness is that the names of some of these technologies in the public cloud, they're not one-to-one, right? For example, Service Bus in Azure does actually a couple of these things, right? So it's like, wait, so are you telling me Service Bus isn't a bus system? It is, but it's also, you can use it for queuing. So those confusing parts of English and how that maps to marketing and how that maps to actual technology you can implement in a cloud solution is confusing. So I'll try to give you a little bit of a practical decisioning process you can use as to which do you want to use a queue, a bus, or a stream. So let's talk about integration patterns in general, and in a sense to establish a baseline. I don't want to spend a lot of time here, but I do want to kind of, level set with everybody about how we used to do this prior to these event-driven patterns, and kind of the consequences of some of them. The first one I'll call is the database-oriented, right? When I first got into writing software, in the enterprise, it's closing on 20 years ago. Almost all the integration we did was this, which is we had a source database. Frequently, if you could connect to it over ODBC, right? I mean, those who know the language of interconnection, connecting to a database would say if we can connect to it through ODBC, we can suck data out of it. There was this really common and then put it into a target, right? So there was this notion that if we could extract the data, we could transform the data, we could load the data into the target. Obviously, there's been lots of religious wars recently about this notion of extracting the data, loading it into some sort of intermediate place like a data mart or a database, making the extraction and the load simple, and then letting transform come at the end. Lots of wars have been, lots of discussions have been had about is it ETL or ELT. That doesn't really matter. Ultimately, in this pattern, just know that there was a database. We were connecting to the database. For the most part, there was a scheduled job. We were usually sucking data out of the source system in a batch, and it was traditional databases, right? These weren't APIs. We weren't connecting to them through anything other than an ODBC or a JDBC driver. I mean, that was it, right? Well, scheduled means it lagged, right? This notion that things have increasingly needed to be, or at least the expectations of customers are that they need to be a little bit more real time. I want to know if something happened in my source system, not 12 hours, 24 hours, not every week, right? I want to know within hours or minutes, even in some cases, of when it's happened. So this lag that happens when you've got these scheduled jobs is a problem. Batched tended to be slow, right? If you are going to batch it up and run it every week or every day or every 12 hours, often for fast-moving systems, that would end up netting out to being a lot of data. And so batch ended up being sort of a slow, could be an expensive or a brittle way to do it, so that if you had an error in a particular piece of information you were trying to suck out of a record, well, let's say, suck out of the source system and push somehow transformed into the target, if something got weird in the middle, it tended to, not always, but it could have led to a sort of brittle process where you had to go back and retry the whole batch because you had a bunch of related data. And again, traditional, as I said, it invoked not APIs, but which are, of course, wildly popular and really almost the most common way we access data in third-party systems or in systems we want to integrate with SaaS and others. ODBC is less and less a pattern, certainly not an exclusive pattern anymore. So The next pattern I want to review really quick is middleware oriented. It's sort of funny. I'm doing this on purpose. It's a little bit of a joke, but it's not really. Middleware oriented is really the same pattern. Like I'm gonna fast forward my progressive reveal just for the sake of time, but also just to show you, yeah, same thing, right? Second verse, same as the first, minus one slight variation, which is rather than batching up and pulling over an ODBC connection, we would batch up and pull from APIs. And some of this reflects the fact that in the days when we did this approach, we were really just sort of invoking the same idiom, the same architectural pattern of the database oriented. We were just doing it against APIs, which again, in a way, made it more modern because now systems, all these software as a service systems that you don't have direct access to the database, you could now invoke the old pattern of hooking into the database, by proxy, by way of an API, but it, really was the same pattern again. Then you sort of had, and you may have even leveraged something like this. I called it, again, these terms, lots of books, lots of sites, lots of marketing material, lots of architectural documentation call these things different terms, and so I decided there wasn't really a single way to refer to these things. So I'm calling this pattern though push message oriented because, I'm sure you've heard of the term webhook, right? I mean, a lot of these software as a service or even just API-oriented products, even if you're self-hosting, they offer the ability to send out to emit events and fire those events and post, I say fire, literally there's an HTTP post capability to be able to post that event to a webhook. So the idea that you could emit an event, so like, for example, if something happened, somebody bought a product, somebody registered for a service, somebody, I don't know, deleted a record even, you have the ability to fire a webhook, essentially post an event to a service. So some sort of service that would be sitting out here. Again, it's almost always an API that you hosted somewhere, and then it would catch it, it would transform it, and then it would forward it on to wherever you wanted to put it, right? So the idea would be in this push message oriented pattern, it was a lot more real time, and it is. I mean, this is, by the way, a common pattern right now. I mean, all of these are common patterns right now, right? So I would call none of these legacy. I deliberately didn't call them legacy, right? Because there are examples where the database oriented pattern or the middleware oriented pattern or this push message oriented pattern is the right pattern. I mean, it's the right way to approach the integration. And the beauty of this pattern is it was near real time, right? I mean, the moment or just soon thereafter that the thing happened in the source, the webhook was firing, it was pushing across to this transformation API that would capture the push and then forward it, right? So in a sense, it was as close to real time as you get. And of course, because it was happening at the record level, these payloads were small, they were fast, they're fairly nimble. Obviously, this transformation service might have to reach back out to the source to get more data to enrich what it actually ended up pushing to the target. But yeah, for the most part, you had an API, the webhook would fire, or the event fires. There's several other kind of ways to do this, right? But webhooks are the most popular today. It would call a post to an API. That API would then collect it and often would transform it and simply forward it on to the final target or push it again. Now, there were some interesting risks and questions that came up with this pattern. So if you've used this pattern, or at least you've had to think about some of these issues and risks. What happens if the target system is down? If I've got this API sitting here, by the way, can somebody give me a quick confirmation? Can you see my mouse? I'm moving it almost like you can. Can you see my mouse? Moving?
Yes.
Okay, good. I just wanted to make sure I was like pointing at some things that I'm like, oh, well, can you see that? Yeah. So if you have this transformation API in the middle, and it's ready to get things from, get posts or pushes from this, push message pattern, what happens if this target's dead, not there? Like down for maintenance, down because there's a problem on the internet between the API and the target. In this model, it tended to be somewhat brittle. The whole thing would die. Well, crud. Not only does that mean the thing didn't end up getting pushed to the target, that also means that the event that caused this API to fire, it's probably also gone, right? Because the source emitted that event, called the API, fired the webhook, pushed it to the transform API, or the webhook API, right? Pushed into or posted into the webhook. But that was the event. Like, you got the event because it happened, but now it's gone. So like, if this target thing isn't there or somehow isn't accessible, that API and the event are also, in a sense, dead. What happens if the target system is slow? So it's not down, it just is slow. I mean, there's lots of reasons, both internet-based as well as service-based, where now the target, it used to respond in, 30 milliseconds or less. Now it's taking a minute and a half to receive a push from one of these trains. It doesn't mean it's down, but there are lots of reasons why this target could be slow. And what happens if it's slow? Because obviously, whatever's hosting this API, it may not be able to hold but so many open connections at a given time. So the whole API itself could sort of fold in on itself if this got to be too slow. What happens if we need to add more targets later, right? I mean, this API becomes almost a little bit of a bottleneck. And if we just simply, we could, right, add another push target, in this API, we could modify it slightly so that it said, okay, it's going to receive a webhook post to this API, and it's going to push to this target, to this target. But it's a little bit of a, point-to-point kind of approach, and you're modifying heavily this API. And so from a change management perspective, it gets a little heavy because you're basically every time you're kind of going back to the thing. Oh, by the way, it introduces regression bugs, right? Because I had this whole chain working for one system, and now I've got to modify this API again to accommodate a second system. Oops, I just introduced a regression bug that now my first push doesn't work anymore. And so it just would get brittle. And what happens if the source overwhelms the middleware, right? What happens when there's a lot of events happening at the source? Like all of a sudden there's a spike, major buying event that was unforeseen. So maybe this is an e-commerce store and people are buying products. And so every time somebody buys a product, it fires a webhook, which does this little thing. And this API, he's hosted on pretty decent infrastructure sitting here in the middle. But now all of a sudden he's overwhelmed, right? Because maybe he wasn't designed or hosted in a way that was highly scalable. And so now that the fact that this source is emitting 10, 50, 100x the number of events per second that it normally would, this API in the middle can start to fall over. And then lastly, what happens if we need to enrich the target push? So we talked a little bit about this, right? The transform API could reach back out to the source. It could reach into other systems, maybe that I have pictured. I'm not, I'm pointing into the air, right? But so maybe we've got another third-party service that we need to bring data into. Again, part of the consequence of that is we've elongated the amount of time for this transform push to happen, which creates bottlenecks, right? And could overwhelm, if this round trip sort of takes too long, then whatever infrastructure is hosting this API may not have enough memory, may not have enough disk, may not have enough processor to kind of keep all those things going in the process. And so the question is what happens when, I guess what I'm saying is how do we scale the complexity of this API? And so anyway, these are questions, these are risks. Certainly I've gone through a couple of ways in which that doesn't scale well. And so what do we do when we're in that scenario? By the way, I didn't say never use the push message oriented pattern. Sometimes it's right. When you've got a single target, you've got a single fast moving transaction, you're leveraging PaaS to host this API, you might be okay, right? But these are questions. That's why I called them questions and not issues or risks exclusively. Yeah, you may find yourself going, I actually don't know the answer to those questions. By the way, if it goes bad, if question turns into risk, that's a problem for me. You have this pattern, which is what I'm calling the loosely coupled integration pattern. Now you might say, I thought we were talking about buses and queues and streams. Well, generally speaking, by the way, tired old diagram. I did this on purpose, by the way, but I knew you guys would get sick of seeing my source and target, cylinders by the time the thing was over. But yeah, there's this idea that you would publish or issue or send an event. Again, like our webhook API, right? The notion that this source might call a webhook API, but we're going to treat that like it's publishing an event. And what we're going to do is we're going to have this thing in the middle that's going to be a queue or a bus or a stream. So again, we'll call this generally speaking, we'll call this a loosely coupled integration pattern. All three of these solutions fit this pattern. So whether you're using a queue, a bus, or a stream, all of them are loosely coupled integrations, because what happens is when that event gets published, you put it somewhere. Which that solves the problem of the event sort of dropping away, right? So now if this target's not accessible, we've put the event somewhere. And then we're going to make these targets either poll or listen to the events as they hit this little intermediate thing, or just simply subscribe. And this system's going to take care of managing all the subscribers and pushing directly to them. But there's this now loosely coupled relationship between the event, the source, and the target, so that now all the brittleness we talked about a minute ago isn't as much of an issue. All the issues we identified earlier, or the questions we asked earlier, are not an issue anymore. So Just to provide you some perspective on how people historically, pre-cloud, would have solved this problem, there's a queuing technology. Redis is certainly one of them. There's lots of buses technology, but if you've heard of RabbitMQ, it certainly serves that purpose. Streaming, which by the way is a slightly newer, and if this was a family, streams would be the youngest brother or sister of the family, right? This pattern hasn't been in the world as long as queues and buses, but yeah, I mean Kafka certainly solves the data streaming problem. Here's the issue, right? Pre-cloud, or maybe I'll say it without cloud, these require more hardware, like to host Redis, to host RabbitMQ. I mean, you've already got hardware hosting your source if you're hosting this yourself. You already have hardware hosting your target if you're hosting this yourself. You already have hardware that's got to host, I don't know, the webhook APIs and stuff, all the stuff we mentioned. This is just more hardware. It's more stuff to host. One of the issues with, of course, and by the way, this is a cloud solution. I mean, this is what the cloud often helps us solve. But if you've got, variable workload, and as we described earlier, you may not be able to trust that either the stuffing here in the middle, the source itself, or the target can handle variable workloads, like, running along steady state, and all of a sudden there's this massive spike of events that either happens at the source or happens in the middle or happens in the end, because again, more users, systems, or whatever are influencing this target. We talked about what happens if the target is slow. The target might be slow because there's so many users hitting it, right? So variability is certainly a thing that if you are going to buy a bunch of hardware for this, you'd have to over-provision that hardware to absorb that variability. And again, resiliency, redundancy, so not just more hardware to absorb capacity, but also, the ability to make it fault tolerant so that, like, if you lost a data center or if you lost a whole rack of machines, you'd be able to fail over. That requires even more hardware. And by the way, there's, all these systems, if you've ever been a part of teams that have had to maintain them, they're not for the faint of heart. I mean, they're not, they require lots of advanced specialized knowledge, often specialized staff, which by the way, introduces even more complexity and cost to the solution. So this pattern, I think, solves some major problems, particularly those that we identified in the earlier slide. So using queues, buses, and streams solve those problems. But yeah, if you're going to host those things yourself, that introduces another layer of complexity. So, not surprisingly, the result is only the largest organizations could often afford to deploy these systems at scale. So, like, if you were a part of an organization that operated Redis, RabbitMQ, or Kafka, I always say it wrong, Kafka, then yeah, you made an investment. But otherwise, you couldn't justify running these things yourself because, you may not have the money or the people or both. So, PaaS to the rescue. By the way, this is a little bit of a preamble. It's a lot of a preamble. I'm going to start moving more quickly, but I wanted you guys to have a steady base of why we're here. So, platform as a service, as you all know, allows you to get access to services in the cloud, in one of the three major public clouds or beyond, for a fraction of the administrative overhead of actually managing the VMs, the operating systems, and if, obviously, if you're not in the cloud, the hardware. And so all three of the major public clouds, and this is where the guts of our talk today will be about, will provide value in these buckets. So you've got storage queues, simple queuing service, cloud tasks. You've got buses, service bus, event bridge, and service called PubSub. And then lastly, for streaming, you've got event hubs, Kinesis data streams, and data flow. So let's keep working. So queues. So what are they? Well, they're a durable message store. So what I mean by durable message store is they're just a place to store messages. So as a system, we talked about that little diagram. Again, I wanted this to be etched in your brain, which is why I showed you those two cylinders so many times. In our source cylinder, that source is emitting events or things are happening in that source system, which is causing our things that we might want to integrate or respond to. And so again, a queue is a place to put those events, so that, like, if something happens in the process, we've at least put them somewhere. And queues tend to focus on a single consumer. So again, if you can imagine, you've got a source system, a single target system, and you want to integrate between those two, queues actually provide a good pattern there. So when to use them? I mean, when you have a single consumer or subscriber, you'll hear me, by the way, use the term consumer, producer, subscriber, publisher interchangeably a little bit, consumer and subscriber interchangeably, and producer or publisher interchangeably. They are different technically, but in this talk, we'll talk about them like they're the same thing, because really, for all intents and purposes, they are. And if you want to give some control to the actual publishers or the people creating events, or the systems creating events, then you would use them. When to avoid them? I mean, if you've got latency or rate concerns, meaning your system's going to generate a ton, and you already know this, right? It's going to generate a ton of events. We'll talk about what ton of events means in a little bit, but we're talking about, hundreds, thousands, or even tens of thousands of events per minute. I mean, queues are probably not your deal. I mean, that's not the right way to think about, particularly PaaS queuing. It's not that these technologies can be scaled in this way. It's just that most PaaS solutions for queuing are not designed to meet that demand. If you're going to use multiple subscribers, right? If you're going to have a single producer emitting events and you're going to have multiple subscribers listening to those events, queues are not the thing, right? Because queues are oriented to have messages coming into a queue and then leaving a queue with a single message or event consumer. So you don't benefit, perhaps. Maybe another reason to not use a queue is you don't really care whether or not the publisher gets to influence how the consumer consumes them. We're going to talk a little bit about routing and subscriber controlled filters in a minute when we talk about buses. But yeah, if you need routing, then you don't need to use queues, because that's not what it does. To keep things moving, I'm not going to go through each one of these. The main one I'll highlight is when you have queues, one of the things that in all three public clouds, these queuing technologies guarantee is that they will deliver a message to the queue and to the subscriber, to the poller of the queue. Again, polling. By the way, just to kind of keep it clear, theoretically, queues are polled by consumers, so it's not a pure publish and subscribe pattern where the middleware, the part in the middle, is actually sending to downstream subscribers. Again, it's a little bit of a theoretical nit, but yeah, typically when you've got queues, your consumer of those messages on the queue are actually hitting the queue every once in a while to say, hey, you got any more messages for me? But the idea is that none of these PaaS products will guarantee that they won't deliver the same message in the queue twice. So your consumer needs to be able to deal with that. If you want your consumer to treat an identical message as really just one message, because really it's only it represents a single business or application event, you're going to need to build your consumer in a way that supports idempotency. I can't ever say that word right, but basically the idea is that it treats duplicate events as though they're the same event. And again, you see some of the features there. We'll get into this more in a minute. But buses. So what are they? Now, buses are more complicated than queues, which is one of the reasons why, by the way, when we get into the specific cloud support of these guys, you'll see that Azure Service Bus supports both queues and buses, is because, really buses are in some ways a more advanced use of queues, but they are different. So it's a complex, durable message store with a focus on multiple consumers. So buses tend to focus, where queues tend to focus on a single consumer of an event. Buses tend to focus on multiple consumers. And they do this through this kind of multi-subscriber pattern. So a event producer, again, think about our two cylinders, right? A source system that's emitting events simply does that, right? They emit events or they produce events. And then you've got a subscriber, by the way, that could be one, could be 1, 2, 5, 10, 15 subscribers. Once they subscribe to the bus, they will each receive a copy of the message or a copy of the event. And so the other thing that's nice about buses is, from a loosely coupled perspective, producer, the guy emitting events, consumer, the guy consuming events, or subscriber, have no knowledge of each other. So there's no connection. So we talked about the ability in certain respects for the producer of an event to control timing, as an example of this, right? A lot of queuing technologies will allow a consumer to put a message on the queue, but say, don't show it until tomorrow. or don't show it until 15 minutes after I produce it, because maybe the system who produced the event wants to be able to go back and delete the event because maybe something happened. So queues have this kind of control, whereas buses do not. Buses, you put a message on the bus, it's kind of a fire and forget it thing. All the subscribers who care about that event on the bus subscribe. Now subscribers can, this is like fourth bullet in the middle, can control which events they're listening for. So, whereas they don't necessarily know much about the producer of that event, they can say, I only want this sort of type of event to come to me. In that case, buses become a great solution. And then if you have larger message sizes, and 10 megs and up, meaning you've got a big old payload, you're trying to route, and again, think payload XML, JSON, something like that. If you have fairly large versions of those and you're not dealing with small messages, but buses tend to be the most scalable platform, especially in PaaS. I mean, you can make queues and streams go bigger, but typically that's not the pattern when it's a platform-hosted solution in the 3 public clouds. When to avoid them, right? When you don't need the complexity. When queues would do, you don't need buses, honestly, so don't use them. Or when you have extremely high message volumes. We'll talk about which of the 3 solutions. We talked about that again in queues. Queues and buses really aren't the best if you're producing, if you think about clickstream traffic, or clickstream feeds. So you're trying to, you're literally tracking every place all of your users across your site are where they're clicking, right? That's literally thousands of events, potentially, maybe even tens of thousands or hundreds of thousands of events per period, minutes, perhaps, depending on how high volume your site is. That would not fit in a bus. It just wouldn't. That's not the use case that it goes well there. Or buses, by the way, tend to be, and again, if you remember, we talked about the difference between queues being polled. So your consumer actually sits there and goes, hey, queue, do you got any new messages for me? Hey, queue, oh, I see one. I'm going to grab it and I'm going to use it. That's kind of generic, right? I mean, it's fairly easy to imagine that any consumer anywhere could just do that thing. Whereas subscribers, where basically there's usually a subscriber-specific SDK, it's talking to the bus that basically says, hey, register me as a subscriber and call me when you have a new event for me. There's generally a smaller pool of clients that support each one of these 3 buses and PaaS. So if you have really high, like maybe you've got a Unix box that needs to consume messages from something like a queue or a bus, you're going to get better support for that in queues than you are with buses. So anyway, we talked about this true publisher subscriber, or pub sub, it's often called, a pattern. So there's no polling involved. The infrastructure of the bus is actually pushing to all registered subscribers. It's truly a loosely coupled pattern, and like I said, larger message sizes. So streams. What are they? This is one thing that gets a little bit weird, right? Because I think it's fairly easy to distinguish between queues and buses. Streams actually overlap quite a bit with the former 2, with one major difference in capabilities, and therefore, the reward for the additional complexity. Because there's some additional complexity with streams, but the reward is this one major difference compared to buses and streams. First of all, they're durable, high volume, low latency. Streaming technologies almost always were built for scale. In fact, so much so, you will often, again, just to sort of help you navigate the architecture, right? You might Google for streams, you might Google for Kafka, you might Google for Kinesis or Azure Event Hubs, and almost inevitably, the stuff that's going to hit you immediately is big data or IoT, right? Not because that's the only places you can use these, but this is where if you've got massive amount of events, and you need to have those events processed very, very quickly. That's where streams come in. Now, again, it's not the only place you can use it. And in fact, we've seen streams used in lots of what I'll call more normal integration use cases. But yeah, that's why they show up a lot there, is because they're extremely high volume and low latency and scalable there. So the primary difference, though, in addition to being higher volume and lower latency, the primary difference between streams and buses and queues is that, unlike queues, and buses where the message once processed is effectively gone. Like once a subscriber in a bus, or we talked about a consumer doing long polling or polling of a queue, once they kind of process the message, that for them, the message is gone. And again, in a queue, as an example, a queue, once it's pulled off the queue, and that, often single consumer, because again, if you think about it, if you want consumers listening to queues, typically you don't want consumer A stealing the message from consumer B, C, and D, which is why it typically is a single consumer pattern. In that case, once it's gone, it's gone. Whereas streams keep the message. So when a message enters a stream, it stays in the stream. And so you, as a consumer now, as a caller, again, if you think about source and target and middleware, right? As somebody on the right side of our little, chevrons in the middle and two cylinders on the outside, you now can go back in time. Oh, and by the way, it supports, and again, we'll talk about when to use them, when your consumer would benefit from access to message history, allowing subscribers to get caught up on anything they may have missed. So this is helpful when it's high volume, because you can imagine, if you've got 1,000 messages coming across a second, I might have 6 registered subscribers, and they came up, within minutes of each other. Well, that could net out to lots and lots and lots of missed messages or context that those consumers cared about. And so this is where streams keep the message for some period of time in the stream, allowing consumers to go back in time and get messages that are not necessarily the most recent message to enter the stream, but allow them to get caught up. This is one of the reasons, by the way, we talked about big data. This is also why if you're looking at streams in the cloud, you'll often run into stream analytics solutions. Because you can imagine with 24 hours or a year or some amount of time holding messages in the stream, it's a little bit like a database with each message being a record in a table. So there's the ability to, Power BI and Click and Tableau and all these products, they can talk to streams, be it Kafka, be it Event Hubs, be it Kinesis, to effectively treat the stream almost like it's a database. And so that now you not only do you have access to the message, to the previous events or messages in the stream, but also as new messages show up in the stream, and again, you can think about a real-time monitoring scenario where you've got, as I said, maybe 1,000 messages hitting the stream every second. Not only do I get to go back in time, once I've wired up my analytics to the stream, I get almost real-time data hitting my portal stream, coming across that stream. So this is where stream analytics, by the way, that's not the same as streams, right? Streams is the underlying data store, but this is why if you start to Google for streams, all the different technologies that deliver it, you'll run into stream analytics solutions as a part of that, because often that's how they're used. When to avoid them, right? It's like if you just need buses, just need pub sub, you just need queues, don't do streaming. It's complex. I mean, it's more complex. It requires more complexity on the consumer side. It requires more knowledge, and candidly, it's a little bit more difficult, even though you're in PaaS, to configure them initially. So yeah, you don't need high volume. You don't need consumer complexity. You don't need the complexity in general. You can accomplish the same thing using buses or queues. Use those. Or if you need larger message sizes, by the way. Now, of course, there's a big continuum, right? Larger message sizes probably means we're not moving as quickly. But the idea is you do want buses, probably, if you're talking about bigger message sizes, in part because most PaaS offerings of streams only support a message size of a meg or smaller. So, by the way, that's, in JSON terms, XML terms less so, but in JSON terms, that's actually a pretty big message. But yeah, for the most part, just keep that in mind. So let's talk, I'm going to spend a lot of time here. I just want to orient you to what cloud solutions are out on the market. So we're going to do this one at a time, but I'm going to move fairly quickly. We'll do it in each cut, right? So queues, Azure, actually has 2 really good queuing technologies. I gave you a foreshadowing of this, so it won't surprise you when I say it in a minute. But really, there's 2 options when it comes to queues. Number one is to use Azure Storage Service. Azure Storage has a subservice called storage queues. So you can create, I've showed an example of this in both the portal and the Azure Storage Explorer. You can create a queue from either of those, and voila, you've got a queue. And it's a really simple implementation of queuing. It supports, most of your common use cases. Now, it's where the biggest part where queues will actually begin to break down through this service is latency. They don't have high performance. Queuing in a storage account is subject to fairly low. It's not slow, but it's just not. If you got a high volume app and you need to be able to push messages onto the queue really fast, this could break down for you. And so where you would go next, which we'll talk about in a minute, is the other service, which is Azure Service Bus. Again, wait, a bus? I thought that was a different thing. It is, but Azure Service Bus also supports the queuing pattern, and so you can actually do queues in Azure Service Bus. This is why it was cloudy, right, guys? I told you cloudy was the operative word, right, because it's confusing. So, but just know that you can do queues in one of two ways in Azure. One is the simple option, a little bit less scalable, but simple option, which is the queuing service in Azure Storage, and option two is Service Bus, and we'll talk about that in a minute. Simple queuing service. This diagram is not meant to be especially helpful, other than to say these are some of the ways that you can use it. Part of what's also fascinating about all three of these platform services, be it streams, be it, and this is true across all three public clouds. One of the ways in which these three services, queues, buses, or categories of services, queues, buses, and streams, empower your deployment of cloud-based solutions is almost all of them directly and simply integrate with the function as a service offering of that cloud. So think Lambdas, think Azure Functions, the ability to write small, lightweight, code-based processors of events exist in these technologies. The ability to be able to do that and then automatically hook that to a queue so that when messages enter the queue, your Lambda is automatically called. This is this sort of example right here, SQS event trigger. So this diagram actually, I kind of copied it from somewhere because it was it's a generic enough example of queues in an architecture. But I just want to, and I mean, you can also have events, in an S3 bucket. When an object is created in S3, you can have it, of course, fire an SQS. You can place a message on a queue and you can do stuff, based on that. So again, just realize that one of the advantages of these platform services, by the way, it's just as true of streams as well as busing technology, which again, we'll get into. But yeah, so if you're thinking about a function as a service or serverless, often it's referred to, approach, these integration models, this loosely coupled model is actually a phenomenal addition. Lastly, cloud tasks. Google took a little bit of a different approach in their cloud platform for how they wanted to manage, or they have, cloud tasks is, queuing technology. That's what it is. I mean, you read all the features in it and it lines up really well with queuing. They also have added a little bit almost like a workflow technology on top of it, and the notion, or maybe a better way to call it is like a loosely coupled jobs technology. So like the idea that you can run jobs based on, so where you might see here queues and Lambdas as separate things in AWS, Cloud Task is kind of almost like a single framework for both of those things, but it is the solution. If you want to have a simple queue, there's lots of places in Google where they refer to they basically say task/message, right? So the idea is if you want to have a message queue, Cloud Tasks is the way to do that at Google. Real quick as I move, because I want to have time at the end for questions. Buses, right? I talked about earlier that Service Bus, you'll see we're on the Azure Service Bus. It supports both the queue pattern, that's this top little diagram, as well as a classic pub sub bus approach where you've got multiple receivers or subscribers, single sender. So the main differentiation between when you would use buses for queuing and when you would use Azure Storage for queuing, don't forget, I mentioned that most bus technologies tend to be a little bit more implementation specific. And so therefore, the SDKs and software libraries that support interacting with buses tend to be a little bit more narrow. So if you want to have as I said, a Unix box at random pulling messages off a queue, you would want to use Azure Storage queues if you're in Azure, right? You wouldn't use Azure Service Bus because Azure Service Bus really strongly implies, and by the way, they have a lot of SDKs, so it's not just .NET or anything. But yeah, I mean, implies you're going to have a fairly robust kind of software framework behind what you're doing. And so then, yeah, I mean, if you have that, then you might as well use service bus for queues. Oh, by the way, there's a cost difference. That should also be mentioned. Storage queues are ridiculously cheap. So that's the other, like, cost never matters to anybody, right? But yeah, if you're wanting something cheap, potentially slightly more heterogeneous, and you don't care so much about the latency or throughput related concerns, then yeah, storage queues are generally a good solution. But if you need a true bus, then the way you do that is with service bus. There isn't really another solution for that. There used to be other things like BizTalk and other things like that, but for the most part, service bus is the way to do that. Down here, sort of a reminder. I kind of said it earlier when I was on the AWS slide. But yeah, service bus, one of the beautiful parts about service bus is there's inherent integration with Event Grid and Logic Apps and Azure Functions and Power Platform and 365, Dynamics 365. And as we said, Stream Analytics, there's also integration with. So, and by the way, we're not on a stream, I get it, but there's also integration between Azure Service Bus and Azure Stream Analytics. So just know that these aren't standalone solutions, that a lot of there's this whole ecosystem of PaaS solutions each public cloud has, and so typically these three options integrate pretty nicely with it. This is a leave behind. I'll let you kind of look at this on your own time, but I wanted to go ahead and give you a full inventory of the service bus features. The equivalent in AWS is a service called Event Bridge. So it is a fully functioning service bus. Again, this is a kind of a generic diagram showing kind of, again, more lambdas integrating with things via Event Bridge. But in this case, you'll see down here at the bottom, you've got kind of an event being emitted, put on Event Bridge and then being subscribed by another lambda. But yeah, I mean, the idea is Event Bridge is functionally equivalent to Azure Service Bus in almost every way. So there's Event Bridge, and then lastly, the PubSub is the service that Google has by comparison. I put this kind of feature comparison for you guys, so you could look at it. Part of these, I see these town halls or webinars as an opportunity to kind of do a little bit of librarianship for you guys to kind of, like, there's 1,001 things on the internet, right? Especially if you're coming in scratch, it's kind of like, where do I even get started? So part of what I was trying to do here is just kind of say, here's a really helpful comparison that Google provides between Cloud Task and Cloud PubSub. Notice how there's this message size limitation on Cloud Tasks. PubSub takes it up to 10 megs. Ironically, in a minute, when we look at the Google Cloud streaming solution, it goes back down to 1 meg. So again, if you have large message sizes, inevitably buses are your best option, and that's pretty much across all three public clouds. Independent of the fact that they're probably completely different implementation cases underneath the covers. 1 meg and 10 meg appears to be the pretty consistent answer for those. Streams. Event hubs in Azure is that. Again, I feel like we've talked about what a stream is, so I don't necessarily need to go into that here. But the idea is, yeah, the ability to be able to take events as they enter the stream, be able to configure, and again, this is all configuration, configure the what happens when or how you want your function app to be triggered off events coming into the stream. And again, you can, and this is a kind of a neat hybrid solution of using a storage queue as what's called a dead letter queue. So you can imagine if a function app can't write, there's that thing in the middle, if that function app can't write for some reason to Cosmos, or it comes out, or there's an error or something strange is going on, you don't want to lose that message. And so rather than relying on its presence on the stream, you can basically create a backlog, what's called a dead letter queue, that says here are the messages that just didn't make it all the way home, and it gives you an easy place to go manage failed messages. And that's a pattern that you'll commonly see. In fact, in one of the earlier slides, you may have actually seen dead letter queue mentioned. It's frequently an approach used even in AWS. This is showing, of course, Azure. But yeah, this is another example of where the streaming pattern is completely supported. By the way, just in case you're curious, Kafka is the winner. If you're going to host, it's complicated, which means you like our first slide described, you better be ready to hire experts to run it, to set it up and run it for you if you don't already have that knowledge in-house. But Event Hubs, interestingly, Event Hubs is the only of the three that is a Kafka compliant service. So I don't know exactly what that means because, of course, I don't work on that product team at Microsoft, and so I can't read between the lines accurately. But what I can tell you I think is going on is I think to implement event hubs, Microsoft has taken and effectively built on top of Kafka. So Event Hubs is a Kafka compliant event streaming solution, which means if you've got Kafka consumers, you can just drop them in on top of Event Hubs. So anyway, that's that. Kinesis data streams. So the equivalent, by the way, which is not Kafka based, I don't think, or at least not Kafka compliant, is but pretty much on point feature wise with Kafka or with Azure Event Hubs is the AWS version of this. One of the reasons why I wanted to bring this is like a really simple. I mean, y'all have seen these diagrams if you've looked at AWS documentation 1,000 times. But part of what I'll bring back to this team or this group today is don't forget these streaming solutions are often solving the problem related to big data, and so you see this relationship to Kinesis Data Analytics, Kinesis Data Firehose, which by the way allows you to apply transformation rules to streams as they're coming across the stream, and so it almost allows you to take one stream and reconstitute it into another stream by doing some, I think they often describe it as ETL. It's not quite the same thing, but yeah, I mean, effectively you're transforming messages on one stream so you can get a different stream. And then, of course, as I said earlier, you can take a stream, much like we saw in Azure. Oops, I hit the wrong button. Much like you can see in Azure, where you've got event hubs firing a function app. You can also have a Kinesis data stream firing an AWS, a registered AWS Lambda. And lastly, this is the equivalent cloud data flow. I knew by the time we got to this point in the deck, I'd basically be repeating myself. So I'll say it one more time, and the good news is we're done. Second verse, same as the first, right? You've got an equivalent data streaming product in Google Cloud Data Flow. It is apparently nobody can agree whether or not the F is capitalized. I looked 15 different places, and in some cases, even Google themselves capitalizes the F and doesn't capitalize the F. So who knows if it's data flow, or there's no space. And I can tell you there's no space in data flow. That's pretty consistent. But anyway, again, very similar approach, very similar downstream supported integrations. Not any surprise there. Oh, and obviously in this particular diagram, which I sort of grabbed off the wide world, is strongly oriented to a big data solution, which is why you've got Hadoop and Spark in there. By the way, that's not the only place. I'll say it again. That's not the only place where you'd ever want to leverage streaming. But yes, it does show up because of the ability to support high volume. It does show up in big data a lot. Lastly, let's go through a really fast decision process. So if you have extremely high message volume, use a stream. So if you have an extremely high message volume, like thousands of events per second, you're probably going to want to use the stream. If you have subscription time variability, that's a really fancy way of just saying your consumers may come in at different times and they need to replay the past. They need to get caught up basically with the stream. They don't want to miss anything. Then yeah, you're going to want to stream. So notice how both those branches sort of go up to streaming. But if not, if you don't care about that, do you need multi-subscriber, routing, filtering, a true pub-sub pattern? Then you want buses. No, if you don't care about that. Do you care about publisher control, single subscriber? Then yeah, you want queues. So, and by the way, of course, this last question is a little bit hard to show in kind of a pure decision process. It's not like streams is the right answer until buses is the right answer until queues is the right answer, right? You may come in and go, no, I actually need to control when my consumers can see a message. None of these other options provide that solution. So like you would want to jump straight to queues in that case. And obviously if you've got a single subscriber, you just may not need the complexity of these other patterns. All right, so with 5 minutes left, I actually think I managed to get us done with 5 minutes left. What questions do you all have? Hopefully this was valuable. The content is a little bit heady if you're not living in an integration architecture or a solution architecture or a solution engineer role. So hopefully this wasn't too much for people. But what I really want to give you all the perspective is PaaS and cloud has changed in many respects our access to really dynamic, powerful, scalable technologies, to the extent that what would have previously been kind of we're not a big enterprise, so we can't use that pattern. Now that excuse is gone. And so and I say excuse, and now you've got this wonderful power at your fingertips. And so this is where queues, buses, and streams are now available to you. And so I thought it might be helpful to hopefully clear some of the confusion there. So yeah, any questions from me before we take off for the day? Or comments, war stories, success stories, failure stories. Anybody have any thoughts? Now is when I get to that point in the webinar when I hope everyone is listening, or that I am still being heard by someone somewhere. Oh, good. Chad just smiled, which means we're still here. Good.
Yeah, I'm still here.
Well, good. Guys, thank you for the time today. If you have any questions, now would be the time. But I'll say one more thing and I'll give you one last chance. If you don't have any questions right now, or if you're like, whoa, I got to soak all that in before I actually have an articulate question, fine. Please feel free to set up some time with me. I'm really passionate about this domain because it really has, I think, changed the way we think about integration. And integration, as we know, is the default expectation. Gone are the days when you're like, well, I guess we got to do that manually with CSVs and people like that. Yes, people still do that, of course, but that's usually a compensatory, like we failed somehow kind of expectation. And so integration is, of course, the baseline expectation. And so I think it's really helpful to kind of leverage some of these patterns. So let me know if you have any questions in the future. It would be helpful to spend 30 minutes with me. I'd love to do that. But yeah, last call. Any questions today? All right. Well, thank you so much. I'll pass it back to Chad to wrap us up, and y'all have a wonderful day.
All right, everybody. Thanks again for attending. You will receive a recorded version of today's talk. As Eric said, certainly if you have any questions, if you have specific questions regarding your environment and a project that you're undertaking, feel free to contact Eric directly. A lot of you know how to contact me. So we look forward to talking with all of you again. And thanks to everyone once again for attending today. And now let's all go to lunch. See you, everybody. Bye-bye.
Thanks, guys.